नमस्कार विद्यार्थी मित्रांनो, काल झालेला गणित भाग 1 चा पेपर आपणा सर्वांना सोपा गेलाच असेल। आपण गणित भाग 1 चा जो व्हिडिओ पाहिला आणि छान अशा कमेंट्स दिल्या त्याबद्दल मी आपला सर्वांचा खूप खूप आभारी आहे। तसंच उद्या गणित भाग 2 चा जो पेपर आहे त्यासाठी मी श्री संजीव साहेबराव वाखरे, सहशिक्षक श्रीमती गेंदेबाई ताराचंद चोपडा हायस्कूल आणि ज्युनियर कॉलेज चिंचवड आपणा सर्वांना उद्याच्या गणित भाग 2 पेपरसाठी हार्दिक शुभेच्छा देत आहे। आणि त्यासाठी जे काही मला परीक्षेला जाताना काय काय माहिती पाहिजे, मला हे येते की नाही या संदर्भात एक थोडक्यात रिव्हिजन घेणार आहे। तर जास्तीत जास्त सर्व विद्यार्थ्यांनी हा व्हिडिओ पाहणं गरजेचं आहे। विद्यार्थी मित्रांनो, देयर विल बी सम theorems in maths 2. At least one theorem will be there. I will explain some theorem you must observe. But remember one thing, while solving the theorem, you must attend the diagram. Without a diagram, there will be no marks to the theorem. So, in the theorem, you must draw a well-knit diagram. With the help of diagram, because with the help of diagram we explain the theorem. So diagram is a compulsory, and there are some steps given to prove if there is essential construction, and to how to prove, that is the proof are compulsory. Now we are going to explain some theorem. First theorem is that basic proportionality theorem. What is the basic proportionality theorem? If a line is a parallel to one side of a triangle, if a line is a parallel to the one side of a triangle and intersect in remaining two sides into distinct point, then that line divide the remaining segment in the same proportion. So you must write given to prove, construction and proof. So without diagram there will be no marks to theorem. But if you have write given to prove and draw diagram, you get some marks. So given in triangle ABC, line L is a parallel to the side BC which intersect to the side AB in the point D and AC in the point E. To prove that AD is congruent to AD upon DB is equal to AE upon EC. Construction, draw DC, draw DB, then you can give proof. So this is the very important theorem. Next theorem is that Pythagoras theorem. What is the Pythagoras theorem? In a right angle triangle, the square of hypotenuse is equal to the sum of square of side containing right angle. So given in triangle ABC, angle B is equal to 90. That means given triangle is a right angle. To prove that AB square plus BC square is equal to AC square. So this is the second theorem. You can give construction and proof. Third theorem is that tangent segment theorem. The tangent drawn from the exterior point to the circle are congruent. Tangent drawn from the exterior point to the circle are congruent. Given O is the center of circle, P is any point outside the circle, the tangent drawn from point 2 to the circle intersect the circle, touch to the circle in the point A and B. We want to prove that segment PA congruent to segment. There will be construction, draw OA, draw OB, draw OP. Then by using tangent radius theorem can you prove given construction, given theorem. Then fourth and very important theorem is that cyclic quadrilateral theorem. What is the cyclic quadrilateral theorem? The opposite angles of a cyclic quadrilateral are supplementary. Suppose that quadrilateral ABCD is a cyclic quadrilateral given to prove that angle BAC plus angle BCD is equal to 180 and angle ABC plus angle ADC is equal to 180. Then you can solve with the help of inscribed angle theorem. This is the cyclic quadrilateral theorem, and one more theorem will be there, inscribed angle theorem. In suppose that this is the inscribed angle ABC in the arc AXC, and arc AC is the intercepted arc. Then inscribed angle theorem says that measure of inscribed angle theorem is half of its intercepted arc. So that 5 theorems are very important. At least one theorem will be there in your question paper. So I request to all, please prepare all this theorem. So now we are going to study what we know in each chapter. First chapter is that similarity. In similarity, there is a question on the properties of areas of two triangles. The ratio of the areas of two triangles is equal to the ratio of the ratios of the product of their corresponding base and height. So there will be question on this area of triangle ABC upon area of triangle PQR is equal to base 1 into H1 upon base 2 into H2. Base into height of first triangle upon base into height of second triangle. But second question will be there, if the base of both triangles are same, then if the base of both triangles, suppose that this is the triangle ABC and this is the triangle BCD, base of both triangle is same. So if the base of two triangles is same, then the ratio of the areas is equal to the ratio of their corresponding height. And in same case, if this is the triangle ABC and this is the triangle ACD, in this two triangle, if the two triangles have common vertex and their base lies on the same line, then their height is same. If the height of the two triangles is same, then the ratio of their areas is equal to the ratio of their corresponding base. So in triangle, area of triangle ABC upon area of triangle ACD is equal to base BC upon base CD because height is the same. And if the height and base of the both triangle in triangle ABC and in triangle BCD, line L is parallel to line M. If two triangle lies between two parallel lines, then their height is same. So in triangle ABC and in triangle BCD, they both triangle lies in the parallel line, so there is height is same. And their base is common, means base is same. If the base and height of both triangle are same, the ratio of the areas of that two triangle is 1:1, means their areas are congruent. So depending on one question must be there in your tomorrow's question paper. So next is basic proportionality theorem. I have explained theorem, but if there is no theorem for writing, then there will be question to solve the question. In triangle ABC, line EM is a parallel to the BC which intersect point P and Q. This is the 4, this is the 12, this is the 3, find the value of PQ. This is a parallel to this, so AP upon PB is equal to AQ upon QC. By using basic proportionality theorem, you want to solve this. So there will be question on this. Then angle bisector theorem. In this triangle ABC, if BD is the angle bisector of ABC, then that angle bisector divide the opposite side in the same proportion of the remaining two sides. So angle bisector theorem says that AD upon DC is equal to AB upon BC. Depending on, there will be question, angle bisector theorem. Next question will be properties of three parallel lines. Suppose that this is the line L, this is the line M, and this is the line L, which are parallel to each other. This is the this is the transversal, and this is the another transversal. The intersect made by first transversal P is AB and BC, and if the line Q made the intersection X, Y, J. Properties of three parallel lines say that the ratio of the intersection made by one transversal is equal to the ratio of the intersection made by second or any other transversal. So AB upon BC is equal to XY. AB upon BC is equal to XY upon YZ. This is the properties of three parallel lines. Depending on, there will be question to you have. Now we are going to next that similarity of two triangles. What is the similarity? If in triangle ABC and in triangle PQR, this is the 2, this is the 4, this is the 5, 10, 7, 40. Their corresponding sides are in proportion. This angle A congruous to angle P, angle B congruous to Q, and C congruous to R. In these two triangles, three sides of one triangle are proportion to the corresponding three sides of other triangle, and their corresponding angles are congruent. That two triangles are similar. Converse says that if two triangles are similar, for example, triangle XYZ is similar to triangle ABC, then you must write side XY upon side AB is equal to side YZ upon side BC is equal to XZ upon AC, and angle X congruous to angle A, and angle Y congruous to angle B, and angle J congruous to angle C. Depending on, there will be question to you have, they are given two triangles are similar, they are given corresponding ratio of the side, and you want to find the other side. This theorem is, these properties also used in the chapter construction, because in construction there is a one construction part, construct a triangle with the help of given similarity. So next question will be theorem of areas of similar triangle. Very IMP question will be there. Very IMP. If two triangles are similar, triangle ABC similar to triangle PQR. If two triangles are similar, the ratio of the areas of two similar triangles, area of triangle ABC upon area of triangle PQR is equal to the ratio of the square of their corresponding side. AB square upon PQ square is equal to BC square upon QR square is equal to AC square upon PR square. One question must be there depending on this. They are given the sides of corresponding sides of similar triangle, and you want to find the ratios of areas, or they have given areas and corresponding one side, find the another side. One question will be there depending on theorem of areas of similar triangle. In this way, we see first chapter completely. Now we are going to second chapter. This is the Pythagoras theorem. In Pythagoras theorem, there is one very important theorem, is that similarity of right angle triangle. In right angle triangle, if we draw perpendicular on the hypotenuse, two triangle form are similar to each other and similar to original triangle. This is the one theorem. Depending on this, we can prove that. Depending on that, there is a new theorem. This is the geometric mean theorem. What is the geometric mean theorem? If in triangle ABC, angle B is equal to 90 and BD is a perpendicular to hypotenuse, then BD square is equal to AD into DC. AD into DC. This is the geometric mean theorem, and one question will be there depending on geometric mean theorem. Then there will be question depending on Pythagoras theorem. We have explained what is the Pythagoras theorem and converse of Pythagoras theorem. Converse of Pythagoras theorem, and they have given 3 numbers, and suppose that 5, 12, 13, and they are asked these are the sides of right angle triangle, yes or not? Then this is the, or this question is also, is this Pythagoras triplet? So depending on Pythagoras, there will be as it is question. So how we can explain the given triplet is Pythagoras, yes or not? The square of largest side, if the square of largest side is equal to the sum of square of remaining 2 sides, then this is the Pythagoras triplet, or these sides are the sides of a right angle triangle. So we will see 13 square is equal to 190 square, 169, 5 square plus 12 square, 25 plus 144, 144 plus 25, that is 169. So square of largest size is equal to sum of square of remaining 2 sides. So this is the Pythagoras triplet, or these sides are the sides of a right angle triangle. Also there will be question on with the help of Pythagoras 30, 60, 90 theorem. 30, 60, 90. If a measure of a triangle, measure of angle of a triangle are 30 degree, 60 degree, 90 degree, the side opposite to 30 is half of the hypotenuse, and side opposite to 60 is √3 upon 2 times of a hypotenuse. Similarly, there will be question 45, 45, 90 degree. If in a triangle measure of angle of triangle are 45, 45, 90 degree, then sides containing right angle is equal to 1 upon √2 into hypotenuse. This is the 45, 90 degree theorem. Then there will be one more question that depending on the sides and relation between sides of a square and its diagonal. Suppose that ABCD is a square, this is the diagonal, then diagonal of a square is equal to diagonal of a square is equal to √2 into side. Depending on this formula, there will be one question to you here. So in this way we complete the Pythagoras chapter. Now we are going to now we will see Apollonius theorem. Apollonius theorem is related to the median. If in this triangle ABC, if AD is the median of a triangle ABC, then Apollonius theorem says that AB square plus AC square, AB square plus AC square is equal to 2 into median square, 2AD square plus 2BD square. 2BD square. One can write also, instead of 2BD square, one can write 2CD square, because AD is the median, so BD is equal to CD. Depending on this, there will be question to you here. So you must remember all these important topic. Now we are going to third chapter. This is the circle. In circle, there will be a small 1 mark question. How many circles are passing through the single point? We can draw infinitely many circles through the single point. How many circles passing through the 2 points? 2 distinct points they are given. We can also infinitely many circles passing through the 2 points. But how many circles we can draw through 3 points? If the 3 points are collinear, we cannot draw a single circle. We can't draw a circle. If the 3 points are given non-collinear, then we can draw a single circle, only one circle passing through the 3 non-collinear points. So next is tangent theorem and tangent segment theorem. Tangent theorem we have seen earlier. The tangent segment drawn from the exterior point to the circle are congruent. Then tangent segment theorem. Now we are going to passing a touching circle. When two circles have only one common point, then that two circles are called touching circle. But if the center of that two circles are opposite side passing through the point of common tangent, then that's are the external touching circle. But if the center of both circles are same side of the common tangent, then that circles are called internally touching circle. And there is one theorem: the point of contact of touching circle lies on the line passing through their center. The point of contact of the touching circle lies on the line passing through their center. Why I explain this? Because there will be one question to you: how find the distance between two externally touching circle or internally touching circle. One question might be there in your question paper. If the circles are externally touching, the distance between their center is equal to sum of their radius, and if the circles are internally touching, the distance between their center is the subtraction of their radius. So touching circle. Then one more question: inscribed angle theorem we have already explained, but there will be question to you here. If this is the inscribed angle, this is the inscribed angle ABD, and this is the intersected arc. If the measure of intersected arc is 40 degree, find the measure arc ABC. You know, measure of inscribed angle B is half of measure arc AXD. By using this, can you find angle B? And also you can find the measure of arc ABD. Now we are going to next that cyclic quadrilateral theorem. I have explained already, but there is question on depending on cyclic quadrilateral theorem. If this is the cyclic quadrilateral A, B, C, D. This is the 2x plus 5. This is the 3x plus 10. Find the measure of angle A, B, C. Find the measure of angle A and C. So this we can use the opposite angles of cyclic quadrilateral are supplementary. By using this formula, you can solve this. Then intersecting chord theorem. If two chords intersect to the circle, intersect in the internal of circle, if this is the chord AB, this is the chord CD, and intersect in the point O, then AO into OB is equal to CO into OD. If this chord intersect to the externally, suppose that AB, this is the CD, this is OB, then there is formula AB OA into OB is equal to OC into OD. Depending on this, one question will be there in your question paper. And next is that tangent secant. Tangent secant, if this is the triangle, this is the line, here is the tangent of the circle which touch to the circle in the point PT. If this is the point Q and this is the secant drawn from the point Q, which intersect to the circle in the point A and B. Then PQ square is equal to QA into QB. QA into QB. This is the tangent secant theorem. Depending on, there will be question to you here. Now we are going to fourth chapter. This is the construction. Very easy chapter is this construction. Draw a perpendicular bisector of segment. Draw a segment 4 cm. Name AB. Draw its perpendicular bisector. You can take more than half. This is the perpendicular bisector. Also there will be question. Draw angle bisector of the given angle. Take this. You already know about this, so I will not waste your time. So angle bisector. Then draw a angle, congruent angle to the given angle without using protractor. So draw any ray. Suppose that this is the ABC. You want to draw angle PQR congruent to the ABC. Take P. Then draw an arc, same arc. Take this distance. This is the congruent arc. Now we are going to next construction. This is the draw a similar triangle. If triangle ABC similar to triangle PQR, AB is equal to 4, BC is equal to 6 and AC is equal to 8, AB upon PQ is equal to 2 upon 3. Draw the triangle PQR. With the help of given information, you can find all sides of triangle PQR, and when you got the sides of triangle PQR, you can construct the triangle PQR. But there will be some question related to this, that suppose that triangle AHE similar to triangle AMT. In this case, these two triangles are not separate. So this construction you must see in the books, because this is a very important question. Now there one more question for construction of tangent. Draw a circle having a center O and radius 3 cm. Take any point on the circle P and draw a tangent passing through the point P. Take 3 cm radius, draw a circle. Take any point on the circle P. This is the center. Now we want to draw tangent passing through the point P. Construct ray, any ray passing through the point O. Take arc less than radius, same arc, then more than half. Construction. This is the tangent passing through the point. So one question will be there, draw a tangent. If they have asked draw a tangent take any point on the circle and draw the tangent passing through the point but without using center, then can you take any point P and you want to draw a tangent passing through the point P but without using center, then draw any chord passing through the point P. Suppose this is the Q. Take any point on opposite side. Suppose this is the. Then what you will do? Take the arc, same arc, then measure this arc, then arc passing through this point and this. Can you draw the tangent? This is the tangent passing through the point without using center. One more question. Draw a tangent to the circle passing through the exterior point. Question. Draw circles having center O and radius 3.5. Take any point P having the distance OP is equal to 8 cm and draw a tangent passing through the point P. What is the construction? Draw a circle having the radius 3.5. Suppose this is the center. We want to take a point P at a distance 8 cm from the center. So measure 8 cm, draw an arc, join this. This is the point P. Then can you draw the perpendicular bisector of OP? This is the perpendicular bisector of OP. And this is perpendicular bisector. So this distance is same. By taking this radius, can you construct the circle which touch to the circle in the point A and P? Now can you draw the line ray passing through the point PA and ray passing through the PB? This is the tangent passing through the exterior point. So this is the very important question for construction. Now we are going to next topic. This is the coordinate geometry. In coordinate geometry, there will be only 4 formulas are important. First one is the distance formula. They are given 2 points and their coordinate. We want to find the distance. The formula is that x2 minus x1 in square root x2 minus x1 bracket square plus y2 minus y1 bracket square. And depending on you have given 2 points and their coordinate, we want to find the distance between them. Then section formula. If this is the segment AB and M is the P is the point which divide the segment AB in the ratio 2:3. The coordinate of A is x1 y1 and coordinate of B is x2 y2. We want to find the coordinate of P, means section formula 2:3 means M/N. Then formula is that mx2 plus nx1 upon m plus n, comma my2 plus ny1 upon m plus n. By using this formula, you can find the coordinate of section point. Then one more question. If in this triangle, this is the median, this is the median, this is the median, this point is called centroid. And if we know coordinate of x1, A is x1 y1, coordinate of B x2 y2 and coordinate of C x3 y3, then you can find the coordinate of centroid. This is the G. The formula is that x1 plus x2 plus x3 upon 3, comma y1 plus y2 plus y3 upon 3. Then next formula is that you want to find the slope of the line. Slope of the line is the formula is that y2 minus y1 upon x2 minus x1. And one more formula is that to find the slope of the line, that is equal to slope of the line is tan theta. So this is the very important formula. You must remind this formula, and by using this value you can solve the example. Then next chapter is the trigonometry. In trigonometry you must know some trigonometric ratios and some trigonometric identities. And you have already known trigonometric ratios. What is the sin theta, tan theta, sin theta, cos theta, tan theta, cot theta, sec theta, cosec theta, and there will be relation sin theta into cosec theta is equal to 1, cos theta into sec theta is equal to 1, tan theta into cot theta is equal to 1. And you must know identities. There will be question, prove that sin square theta plus cos square theta is equal to 1. This is the identities, but you want to give a question, prove it. How we can prove this? In triangle ABC, this is the theta. We know that Pythagoras theorem, AB square plus BC square is equal to AC square. AB square plus BC square is equal to AC. By dividing AC square to the both sides, AC square divide, AC square divide, AC square divide, AC square upon AC square 1, BC square upon AC square, mean BC upon AC bracket square. BC upon AC. Adjacent upon hypotenuse cos square theta. AB upon AC, AB upon AC, opposite upon hypotenuse sin square. So sin square theta plus cos square theta is equal to 1. This is one identity. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. These are some identities, but if they have given sin theta is equal to 5 upon 13, find the value of cos theta by using trigonometric identity. If they have asked by using trigonometric identity, you must solve this by using this formula. But they have not asked by using trigonometric identities. Then you can solve with the help of diagram. This is the triangle ABC. This is the 90. This is the theta. Opposite 5, hypotenuse 13. By using Pythagoras, can you find BC? This is the 12. So cos theta is equal to adjacent upon hypotenuse 12 upon 13. But they have asked by using identity, you must use this formula. This is the main fact while solving the trigonometric ratios. Then there will be, you must have prepare a chart of trigonometric values in the first 10 minutes and last page. This is the chart. Here can you prepare sin theta, cos theta, tan theta, cot theta, sec theta, cosec theta. This is the trigonometric ratio and measure 0, 30, 45, 60 and 90. You must prepare this chart in first 5 to 10 minutes before the 11 o'clock when you have got your answer sheet. Because when you prepare this chart, you can use this value directly. Because while finding the slope of line, you must know the all trigonometric values of tan theta. You can get ready there. So you can prepare this chart. Then you must know angle of elevation, angle of depression. Depending on that, there will be word problem. You must see all the word problem on trigonometry. Now last chapter is that mensuration. In mensuration, you must know what is the surface area and what is the volume. And you must know all the formulas. For example, this is the cuboid. Vertical surface area of cuboid is equal to 2 into bracket L plus B into H. Total surface area of the cuboid 2 into bracket LB plus BH plus LH, and volume of the cuboid is L into B into H. This is the cube. Vertical surface area 4L square, total surface area 6L square, and volume is L cube. This is the cylinder. Vertical surface, curved surface area. In round figure there is curved surface area 2 pi r h, total surface area 2 pi r in bracket r plus h, and volume of the cylinder is pi r square h. This is the sphere. Curved surface area 4 pi r square, volume is 4 upon 3 pi r cube. This is the hemisphere. Curved surface area is 2 pi r square, total surface area 3 pi r square, and volume of the hemisphere 2 upon 3 pi r cube. And there will be one more question depending on area of sector. This is the sector. Area of this sector is equal to theta upon 360 into pi r square. This is the length of arc. Length of arc theta upon 360 into 2 pi r. Relation between area of sector and length of arc, that area of arc is equal to length of arc into radius upon 2. And one more question will be there, area of the segment. This is the circle, this is the sector, this is the segment, and area of this segment is equal to r square in square bracket pi theta upon 360 minus sin theta upon 2. So by using all these formula you can get more mark. So all the best to all students. Thank you.